Welcome. In this video, we are going to do the inference concerning two means when small sample is taken. Here also the null hypothesis that we are going to consider is the same, that is there is no significant difference or the difference is up to this delta value. Okay, when both n1 and n2 are small, population normal with unknown but equal variances. Okay, so these are the assumptions that we take and with which we proceed further. Okay, here note that population normal with unknown but equal variances, and that is why in the denominator we have something different from what we had already. Okay, so this is the test statistic, and here also we are going to have three alternate hypothesis. Okay, whenever we make use of t distribution, student t distribution, here we have the parameter nu. Okay, initially it was simply n minus 1. Okay, here we are considering about two things, so it is n1 minus 1 plus n2 minus 1, which is n1 plus n2 minus 2. Okay, that is the parameter that we have to make use of. Moving further, here note that this n minus 1 s square is the summation of this value. Okay, so with which uh, we will try to identify the variance in this case. Okay, initially what was the variance? It is sigma 1 square upon n1 plus sigma 2 square upon n2. Here we assume the variances are equal, so sigma by this assumption, sigma 1 is same as that of sigma 2, isn't it? So this one we write it as sigma. Therefore, from this, what we get is this one. So we just take sigma square outside, so it is 1 upon n1 plus 1 upon n2. So an estimate for sigma square is obtained by pooling the samples. So with a few alternatives, we get this one. Okay, so if the populations are normal with known variances, use that statistic with me, which means what? Like, we know the variance, in that case we can go with that statistic, right? Okay, moving further, here we have a problem. A random samples of specimens of coal from two mines A and B are drawn at their heat producing capacity in millions of calories per ton were measured, yielding the following result. So we have a result here. So if you notice here, the sample size are different, right? So from mine, okay, so let us list them out. Okay, here n1 is 5 and n2 is 6. Okay, when we just add all these things and take the average, we get that is the sample mean is 8230 for the first case, and for the second case it is 7940. Okay, we can calculate the variance as well. It is 15750 in the first case, in the second case it is 10920. Okay, now let mu1 and mu2 be the respective population means. Okay, we have made the assumption about the population means. Now to test the null hypothesis, that is h naught, which is mu1 minus mu2 is 0. There is no significant difference. Okay, the question is to examine, is there a significant difference between the means at some level of significance, isn't it? Okay, so this null hypothesis is against the alternate hypothesis, which is h1, that is mu1 minus mu2 is not equal to 0. There is no significant difference. Okay, at alpha equals 0.01 level of significance, isn't it? Okay. So further, here samples are small and population variances are unknown, isn't it? Are unknown. So we assume that populations are normal with equal variance. Here we are not making any comment on the mean, okay, since the test is concerning the mean. So we are making an assumption that the populations are normal population with equal variance, and hence we use the t statistic. Okay, when we use t statistic, we need a parameter with parameter new, that is what, n1 plus n2 minus 2, which is, here what was our n1, it is 5, and n2 is 6, so 5 plus 6 minus 2, which is 9, and alpha is 0.01. Okay, so for these values we can find out the table value. T alpha upon 2 was 3.250. Why do we take T alpha upon 2? Because here our alternate hypothesis is mu1 minus mu2 not equal to 0. So whenever you have this not equal to 0, this is falling as a two-tailed thing. Okay, so you would have something like this. Okay, this region as well as this region you are going to cover. Only in between these region we will accept it. Okay, so that is why we just have the level of significance and look at both the ends. So whenever we encounter something this not equal to 0 kind of a thing, we will have to take the alpha upon 2 only, be it a large sample or be it large sample or small sample, whether an inference concerning one mean or two mean, it doesn't matter. Okay, so we have calculated all these things. Now we shall proceed to calculate the test statistic, that is t, which is x1 bar minus x2 bar minus delta upon n1 minus 1 s1 square plus n2 minus 1 s2 square whole thing divided by n1 plus n2 minus 2 multiplied with 1 upon n1 plus 1 upon n2. This whole quantity is under square root, isn't it? Okay, so this is our test statistic. Now we shall apply the values here, minus 747940. So these are from x1 and x2, and we know this thing is, when you substitute all these values and calculate these things, you would get 69.2179. Okay, as a simplification you would get 4.19. Now here what is the case? Since absolute of t is bigger than t alpha upon 2, what can we do? Just go and examine. So absolute of t is bigger than t alpha upon 2. In this case, we shall very well reject the null hypothesis. Okay. Therefore, there is a significant difference between the population means. Okay. Moving to the next question. Here we have samples of two different types of television picture tubes were tested for length of life, and the following data were obtained. They have made our problem simple. Okay, now that we need to check, is there a difference in the means sufficient to warrant that type 1 is superior to type 2. So here type 1 and type 2 mean the type 1 television tube and type 2 television tube. Okay. Now what shall we do? Here let us make the assumption that mu1 and mu2 be the respective population means. Okay. Now to test h naught, which is mu1 minus mu2 is 0, against the alternate hypothesis h1, which is mu1 minus mu2. Here the question is that is the difference in the means sufficient to warrant that type 1 is superior to type 2, which means mu1 should be greater than mu2. So mu1 minus mu2 should be greater than 0 at what is the level of significance. If that is not specified, we are free to choose, right? So we choose 0.01. Okay, this level of significance. Okay, when it is not given, you are free to choose your level of significance, right? Okay, now the test statistic is t is what? X1 bar minus x2 bar minus delta whole thing upon n1 minus 1 s1 square plus n2 minus 1 multiplied with s2 square divided by n1 plus n2 minus 2 multiplied with 1 upon n1 plus 1 upon n2. So for the entire denominator we have the square root, isn't it? Okay. Now substituting these values and simplifying, we would get 10.094. Okay. Now for alpha equals 0.01 and nu equals n1 plus n2 minus 2, which is nothing but 8 plus 7 minus 2, which is 13. So for these values we get our T alpha is 3.012. Here what is the case? Our T is bigger than T alpha. So in this case what shall we do? When this is the case and T is bigger than T alpha, we are rejecting the null hypothesis, isn't it? So we reject H naught. Okay, with which what can we say? So in null hypothesis was that there is no significant difference. Okay, so now we can conclude therefore the difference in the means is sufficient to warrant that type 1 is superior to type 2 regarding length of life. Okay, so that's it for this video. Thank you.